Hi, so for chapter 6 we learned how to calculate the frequency from wavelength. So the first thing we need to know is that the equation C equals lambda times velocity. Now we need to know that lambda equals wavelength and V is the frequency, or 1 over s, which is the same as hertz. So for our example, if we have a wavelength of 254 nanometers, we want to find the frequency. So we're going to take this equation from up here. C equals lambda times velocity. And I'll put over here that C equals 3 times 10 to the 8th meters per second, which is, in physics, the speed of light, but it's also the typical velocity number. So, again, we have a wavelength of 254 nanometers, and we want to find the frequency. So for our equation up here, C equals lambda times velocity, we want to isolate V, because that's what we're trying to find. So we're going to get V equals C over lambda. And now we're just going to fill in the numbers with what we were provided. So V equals 3 times 10 to the 8th meters per second. And that's because that's what C was up here, the typical velocity. And we're going to divide that by 254 nanometers. But there's a problem. This is nanometers and this is meters per second. We need to convert this to meters. And the easiest way to do that is to turn it into exponential form. So basically we're just going to bring it back down. V equals 3 times 10 to the 8th meters per second. And now we'll put down 254 still. And also now exponential form. 10 times 10 to negative 9 meters. Alright. Quick debriefing, we got V equals 3 times 10 to the 8th meters per second, because we isolated V from the problem, and that's the typical velocity. Then we are going to divide by 254, because that's our wavelength. Then we converted that to exponential form so they can work together. So now V equals 3 times 10 to the 8th meters per second, divided by 254 times 10 to the negative 9th meters. And that is going to equal 1.18 times 10 to the 15 hertz, because hertz is the same thing as 1 over s. And we got 1 over s because from calculating this problem, meters cross out, which just leaves s. So that'd be 1 over s, or hertz. And I put hertz because that's easier to put. And that is how you find the frequency from wavelength.